All right, let's go ahead and talk through some of the information necessary to complete the module folder 2C pre-lab. Now, this one's a little bit different. There's not exactly a simulation, and there's not an obvious link involved, um, but I kind of hid the information. So this is a reward for people who pay attention, who watch the videos or attend class, depending on the section. The questions, there are 10 of them like the other ones have been, are based off of the worksheet here. And it even says, but nobody reads this, click on the links and the titles of each page. So if we look, there's even a box around it to show you that it's different in some way, but that's a link. So I'm gonna go ahead and open all of these. Oops, I misclicked there. Okay, and then that way we don't have to keep that part open. So these questions, right? What type of motion do pulley systems transmit between each pulley? So if I go here, pulley systems are used when there is a need to transmit rotary motion. Okay, now these are straight up like junior high level, read the social studies book when there's a substitute day, right? You've got a worksheet and a book, just going through and finding answers. Most of these are going to be really, really obvious, and some of them are even going to give you a hint. So, like this one, technically isn't explained very well on the page, and I think I may have even, oh, go away, maybe not even included the specific page that goes to that one, but we can find a ratio. Mechanical advantage is eventually what this is going to turn into, but a velocity ratio based off of a distance ratio or a size ratio. Well, look, it says divide so that you get a whole number. So if there's only two numbers in here, if there's 800 millimeters and 400 millimeters, divide those, get a whole answer. Okay, then it says here pulleys and lifting page, and so if we look, um, that's going to be this one. It says pulleys and lifting at the top. And then this is why this is nice. There didn't used to be quite so many ads on this, so I'm sorry that's a thing. But we have this animated thing, so it's a lot better than anything I could ever draw because it moves. So your final effort, what I a lot of times call your input, this is where you're pushing and pulling and trying to do something to make this lift. Well, this tension that gets created in the lines rolls over a pulley in the same tension as here. Then it rolls around the pulley in the same tension as here. Then the same tension and same tension. So basically, where these four effort strands or ropes are tied down and eventually picking up that load, they're all multiplying up your force and making things easier to pick up. So if we look, if there are four supporting strands, and these are counted out E1, E2, E3, E4 for effort 1, effort 2, and so on, then right here, you can lift 4 times the normal load. There are 4 efforts. The velocity ratio, mechanical advantage are both 4. They're going to be the same number. Okay, so same one. If I have 100 newtons supported by 4 strands, then that means I've got 4 times the help for whatever I put in. Well, if you had questions on exactly how that was going to work, you could find that down here. This is 2 examples together. So, there's a distance part and a force part. But your advantage, how many times the help do you get? You can turn that around and basically how many times easier is it to do the same job? So here we would have 100 divided by 4. Um, oh, I actually got a little bit ahead of myself. So yeah, mechanical advantage of 4, which was on that same picture. But then 100 divided by 4 makes 25. Okay, so and then what's going to happen here, there's a minor error in a typo in the question. Um, oh, maybe it was fixed. Yeah, it looks like it was finally fixed. Okay. But basically, if you want this load to move, whatever's here to pick up, you have to keep in mind that it's going to move slack out of this string, this one, and this one. So you have to pull a lot more rope out of the system than what this is actually going to move up. If this were to go up by, say, 8 feet, then you'd have 8 feet of slack, 8 feet of slack, 8 feet of slack, and 8 feet of slack. All of that you'd have to pull. Okay? So if we want this thing, if we're going to pull 4 meters of rope, we want to see how this thing's going to move. Remember that 4 meters is going to be split between all the different pulleys. We'd end up with 4 meters divided by 4. So sometimes it's called distance ratio. Here they kept it named as a velocity ratio, but it's the same. So, like I said, that's going to be split between all 4 pulleys. 4 split divided by 4 is 1. Okay, then examination questions. It got slightly cut off in the top of the tab here, but that's this one. And oh no, there's no answers here. But if you scroll down, let's click here for sample answer. And so then it does work, the example. So this is what we're looking at. Okay, so let's read the questions and actually read this time so I don't accidentally skip and go out of order. We have 200 Newton load supported by 2 supporting strands, right? So 2 supports, 2 ropes holding that weight. What's the mechanical advantage? Well, effort 1 and effort 2. 2 supports there. Means the mechanical advantage is 2. Remember, that's also going to be the distance ratio, the velocity ratio, and a few other fancy names, which actually happens to be in the next part. Look. And if you weren't sure for some reason, you could go check. Look, the distance ratio becomes velocity ratio. 2 divided by 1, they set up as 2. But like I said, it's going to be the same as the mechanical advantage. It'd be easier to have gotten it from there. Okay, so then if we want to see how much force that's going to take, you want to pick up 200 newtons of force, or 200 newtons of weight, so it requires 200 newtons of force. But that's from each of the combined from the efforts. So these supports here. If you pull with 200 newtons of force, you're going to get 200 newtons here and 200 newtons here, and that's going to sling this fragile crate in the air. We want to pick it up slowly, barely use enough force. So keep in mind that, our force basically is going to be split or duplicated across these ropes. So if I pull with, say, 100, then I get 100 here and 100 here, which would pull with the right total. If you weren't sure on that process, then again, it is worked out. Use the load or the force you're working against divided by the advantage. And there we go. And then this was the page. I was looking for the typo on the other one. It was actually this one. So yeah, small error there. Nothing really hurts, but yeah, small error there. Okay, so I made sure not to copy that on this one. But if we want the load to move up by 5 meters, how far do we have to pull the final effort? So remember, there's going to be 5 meters of slack come out of here and 5 meters of slack come out of there, and all that rope needs to be pulled through. So if we double check, that's worked out, but also 5 plus 5 is 10, so you might have been able to figure that one out. But there we go. So multiplies by that distance ratio, and then we know we have to pull the end even further. All right, well, that's it.